We spend a lot of time counting calories, but your biology doesn't process numbers, it processes matter. From an evolutionary perspective, tracking energy units reveals very little about how your organs actually operate. The human digestive tract is an ancient piece of hardware. It evolved long before dieticians or digital sensors existed. Instead of calories, it was built to respond to a physical metric, the mechanical sensation of volume. Because the stomach and intestines developed around this requirement to be physically filled, analyzing our diet solely through chemical metrics ignores the physical reality of our anatomy. A reliable way to monitor this system's health is by measuring the physical byproduct of the process. The size and consistency of our stool serves as a direct readout of our internal mechanics. Understanding our health requires us to look past the energy we consume and focus on the physical volume moving through the system. Clinicians use the Bristol Stool Scale to categorize these shapes. It provides a standardized way to look at what we produce and deduce exactly what is happening inside the intestines. At the lower end of the diagnostic spectrum are small, hard, broken stools. These indicate waste remained in the intestines for an extended period, the physical signature of slow transit. Lacking volume, the body must generate significant intrarectal pressure to move them, making defecation difficult. A healthy stool looks different. It is a well-formed, log-like cylinder, typically 4 to 8 inches long. When a diet contains enough bulk, total fecal weight increases. This mass naturally forms the larger shape and ensures material moves through the colon at a steady speed. Producing a large 8-inch stool with ease is proof that your gut is moving at the speed our biology requires, without high internal pressure. To understand why this size is necessary, we have to look at the storage capacity of the internal pipeline itself. The upper tract is built for mass. The stomach can hold up to 1.5 kilograms of material, while the small intestines process between 6 and 12 liters of chyme. The colon holds up to a kilogram of waste, while the rectum has a 300 milliliter threshold. Without reaching that volume, sensory receptors won't trigger a bowel movement. To keep this massive pipeline moving, the system requires constant bulk. Aggregating each organ's capacity reveals a requirement of 500 to 600 grams of dry food daily. Without that half kilogram of dry volume to provide physical push, the large ancestral pipeline stagnates. A large stool isn't just a byproduct, it's the mathematical result of a system operating at full capacity. We can see the results of this high-volume biology by looking at population data from India. A traditional diet in this region provides the exact dry food volume that our ancient digestive tract was designed to handle. Because of that dietary volume, the average daily stool output in India is 300 grams, reaching the threshold our biology requires. Medical data reveals a specific correlation. Populations meeting this 300-gram benchmark see significantly lower rates of colon cancer and higher genome quality. Prioritizing the physical volume required to produce a 300-gram stool is a direct way to support your body's ancient mechanics. It is the ultimate evidence that your internal health is protected.